Welcome to today's webinar where we'll be exploring how you can get the most out of your current assets and essentially do more with less. My name is Ellie Allen Bathe and I'm a content marketing manager here at Flexware. I have just a couple quick housekeeping notes for you before we get started today. First, if you have any questions throughout today's presentation, feel free to drop those in the questions tab of the toolbar and we'll answer those as we go. And then we'll also have a Q&A at the end if we're not able to get to your question as we do the presentation portion. Today's session is also being recorded, and we'll make sure that recording is available to you shortly after we wrap up today. Now that that's out of the way, I'd like to pass things over to our speaker today. I'm joined today by Chris Barnes, who is Flexware Innovations Vice President of Digital Transformation and Industrial AI. Chris, I'll hand it over to you.
All right, thanks, Ellie, and welcome everyone. As Ellie stated, I'm Chris Barnes, Vice President of Digital Transformation and AI at Flexware Innovation, which is a Hitachi group company. So over my career, I have held roles as an engineer, as an operator, as a data scientist, and as a management consultant. And so I have personally been on both the receiving and the leading ends of digital transformation. And I just want to preface by saying that because today I don't just want to talk about the theory, right? Everything that I'll share is grounded in what we have actually seen firsthand working on plant floors. So today's topic is one that I hear very often in my conversations with operations leaders right now, which is how do I do more with less? So let's get into it. So here's a question I want you to kind of sit with over the course of this session, which is where are your actual big losses? If you're like most manufacturers I work with, you can probably point to, I don't know, a dozen improvement projects that are live right now. And yet the gap between your current performance and your targets isn't closing the way that you expected. The thing is, that's not typically a resources problem. It's not even an execution problem. It's likely a strategy problem. And the slide calls it out directly, right? The leverage gap isn't about what you're spending, it's about where you're pointed. Now on the left, islands of automation, point solutions, siloed systems, local KPIs. These feel like progress, but where we need to get to is on the right. Connected data, system level intelligence, leading indicators, cross-functional visibility. That's where the performance gap actually lives. So let's look at why this matters. We'll start by grounding ourselves in why this is happening. And this isn't a cycle. These are structural shifts. Labor scarcity, right? The manufacturing workforce is aging faster than we can replace it. The average skilled trades worker in the US today is approaching 45 years old, and we're retiring institutional knowledge at a rate that we can't backfill through hiring. Number two, supply chain fragility, and we're still reacting to this. COVID exposed just how brittle global supply chains are, but now geopolitical pressures, reshoring mandates, single source dependencies, these continue to force manufacturers to carry more risk, which means you need sharper visibility in order to manage it. And then the third factor, margin compression, right? Input costs like energy, raw materials, and logistics have structurally increased. And selling prices have limited elasticity to the upside, so the only lever left is operational performance. So today, you cannot cost cut your way through growth. You have to operate your way there. And the bottom of the slide says it plainly, right? Good enough is no longer defensible. So here's some of the data behind the mandate. Three numbers, 15 to 25% better OEE in comparable operations, 40% reduction in unplanned downtime, 1/3 lower scrap rates. These are McKinsey and LNS research benchmarks for plants with integrated data and analytics. Now the call out at the bottom matters. Technology is a component, but strategy, integration, and change management are the 80% of the 80-20 rule. And I also want to be careful here, right? There's no silver bullet, but these are outcomes from plants that have done the work correctly. What hopefully is clear is the implication. If your competitors are making these investments and you're not, then the gap is compounding. And this is what's happening now. But the thing is, every manufacturer I talk to is investing, right? The budget is there, the projects are running, and yet the outcomes aren't materializing. Industry research put the failure rate or stall rate at 70% or higher, And when you dig into why, it's almost never the capabilities of the technology. It's often one of the three things that are listed to the right side of the page. So point solutions without integration, great tools, bought independently, but none of them talk to each other. Data islands instead of data infrastructure. And imagine being that plant leader needing to go to 8 to 10 different URLs and applications in order to manage your plant. It's practically impossible. Then the pilots that never scale, the 90-day POC that works, we all get excited, but then 18 months later, it's still on the same line, no scalability plan that was ever built or committed to and seen all the way through. And then data without decisions. And this can be, in some cases, the most insidious of all of these, right? Dashboards and alerts exist, which makes it look and feel like progress, but nothing in the workflow has actually changed. The data's there, it just isn't driving action. And the fix here is not more investment, it's a different approach. So the default instinct when asked to do more with less is to find the biggest waste and to automate it, which isn't wrong, it's just incomplete. So the graphic on the left, you'll see line 1 up 5%, line 2 8%, utilities up 3%, let's call total gain roughly 16%, additive. So these are real wins, but they're disconnected. Now on the right side of the same graphic, same operations, but connected. System level gain with network effects, compounding to 25, 40% uplift overall. Now the difference isn't better technology to each node, it's the connections between them. And the slide tends to make that point directly, right? Manufacturing performance is a system problem. Your scrap rate isn't just about a quality issue, it's connected to raw material variability, process parameters, operator behavior, and maintenance timing. You need all these data assets together. So the question isn't where should I automate next? It's how do I make my operations smarter as a system? Now, let me get specific about three of the common failure modes that limit progress. So first is technology without architecture. So these are the disconnected tools that can't share data, and you end up with silos that are masquerading as a digital strategy. Insights without workflows. Dashboards that show data but lack actionable process integration. It's like dashboard theater, right? Something to look at, but nobody's decisions or actions or routines are fundamentally changed. And then projects without capability. External teams build something, hand it off, and then the internal team loses context. 6 months later, it's running, but it's in a degraded mode without a proper support model. Now the fix is at the bottom. Start with decisions, not technology. And that's the design philosophy that threads through really everything from here out. All right, so here's the answer, right? Simple, 3 layers in sequence. This is the backbone for how we achieve results. Connect, analyze, act. So step 1, connect, build a unified, contextualized data layer, connecting your OT assets, PLCs, historians, SCADA, MES, even integrating with my IT and ET assets, making data usable, not just accessible. And the value unlock here is visibility and baselining levels of performance. Step 2, analyze. So from statistical monitoring to predictive models to AI-driven pattern recognition, the key word here is leading indicators over lagging. And the value unlock is making that step change to prediction and optimization. But step 3, act. Analysis has zero value until it changes a decision. And the design question is who acts, when, and how. And then embedded in the operational workflow should be the analysis process. This is how we get to that value unlock of measurable ROI. So each layer builds on the one before it, and you cannot shortcut the sequence. So let's go one layer at a time. All right, pillar 1 is connect. And the concentric circle diagram on the left shows the key insight that each of these 3 sublayers build on each other. And you can't have a complete solution without having all the parts in place. Now, the other key is that the integration layer is additive. It's not a forklift replacement or a lift and shift or lift and replace. Your existing OT assets, PLCs, SCADA, historians, etc., they stay. You put in a data integration layer above them, And that layer normalizes data into a unified data model that analytics applications can then consume. So there are three design principles on the slide that are worth calling out explicitly. Number one, the integration layer is additive. You're not ripping anything out. Number two, design the data model correctly. This is really important. Operational context matters as much as the sensor value that the sensor is producing. The temperature reading really means nothing without knowing which asset, which product, which process conditions. So then step three, don't connect everything all at once. Start with 3 to 5 high value use cases and build the infrastructure just in time. The specific pieces of the overall vision that those use cases require. And then the rule at the bottom, uh, start with the use case and the reference model, then work backwards to the data that you need, then implement the architecture just in time. And that sequence is really everything. So here's a practical tool that we use at the start of just about every engagement, and you can use it too, data readiness assessment. So the matrix infographic on the left is mapping into 2 dimensions, the business value of the use case and the data readiness to support it. Top right, quick wins. These are high value. The data is ready, execute in weeks. This is where we want to start. The top left, this is my foundation first, right? So high value, but there exist data gaps. What this does is it tells you exactly where to invest in connectivity, and these use cases justify the infrastructure investment. Then my bottom right, these are the nice to haves, data available but lower value, uh, approach them opportunistically. Bottom left, avoid, right? We want to stay away from this quadrant. It's the low value, low data, don't go here. Now the sequencing principle on the right is also the core insight. So action, data, architecture. What action am I trying to improve? What data do I need? Then build the architecture just in time to deliver it. The call out at the bottom is the warning that I often reference, right? Manufacturers who build infrastructure first and then figure out use cases consistently over-engineer and underutilize, and then they come asking, why can I not get my organization's buy-in for what I'm building? Now let me give you a concrete example of the connect layer done right. And this one is close to home at Hitachi Rail's factory in Hagerstown, Maryland, part of our parent group. So opened in 2025, September, $100 million total investment. They're making about 1.5 or design bases, one and a half rail cars built every day, or sorry, one rail car built every day and a half. $30 million dedicated to digital in the build out of this factory. And the choice they face is the choice that every manufacturer faces, right? Build production capability first and then layer digital on top later, or make data infrastructure a priority requirement from day one. And they chose the latter. What that produced was AI quality inspections, digital twins, real-time supply chain visibility, predictive maintenance, live on day one, not a future roadmap, but operational at launch. And that's not all. With this backbone already in place, they're now planning to evolve from assistive analytics to agentic and autonomous, real step change forward. And the principle they applied, it's on the slide in quotes, right? The data layer is infrastructure, not an afterthought. Most of you probably aren't building a greenfield factory today, but the design principle is the same wherever you're starting from, and I'll get to that here in one of the subsequent pages. Now, let's go to pillar 2, so the analyze layer. And this is where modern manufacturing really separates from traditional manufacturing methods. The slide shows the shift visually on the left, lagging indicators, right? OEE at the end of shift, the QC lab results, maintenance work orders. These tell you what happened, but not on a time horizon that allows you to actually capture the value. So on the right, these leading indicators, this is where we need to get to. Parameter drift detection, anomaly, early warning, soft sensor quality inference predictions. These tell you what will happen while there's still time to act. The question that really defines this analyze layer is, what is the process telling me right now about what will happen in the next, let's call it 4 hours, right? Now, predictive maintenance is One of the most cited examples of this at work, the same logic applies to quality, like the use case shown here. Now, AI and machine learning are genuinely transformative capabilities for certain problems. And the graphic on the left attempts to show some of the great uses for these technologies. Dynamic scheduling, real-time optimization across constraints, predictive quality, using soft sensors, inferring attributes in real time, anomaly detection, catching those high frequency patterns that humans just cannot monitor continuously in a practical way, and then multivariate optimization, right? Imagine 20 plus interacting nonlinear variables that just exceeds the capacity of human intuition. But the right column here is also just as important, right? The common misapplications. So AI without the data foundation, garbage in, garbage out, as the saying goes. These are really good at confident sounding wrong answers when the model doesn't know that it's working with bad data. So putting in place the techniques to track these and being grounded in uh, accurate results that are coming in through the system. Number two, AI without the process understanding. This is a big one, right? Correlations that aren't causal levers are often easy to generate, but then the trust erodes quickly when a recommendation made by the AI or by the system just doesn't make any physical or practical sense. And then three, AI without a decision to improve. Beautiful model, good metrics, but zero operational change, right? Nobody designed how the output actually integrates into a workflow to drive action. So the three questions at the bottom of the page are really the test to apply before any AI investment. So what decision am I improving? What data do I actually have? And who changes their behavior based on the output? And if you can't answer all three, you probably don't have a good use case that's worth going after with AI yet. Now here's a real world example from some of my background from years ago with a pharmaceutical manufacturer in a fluidized bed drying process. So we worked on helping a client operationalize a soft sensor model that they had built. So the problem is that in a lot of batch operations, you often can't measure the quality attribute that you care the most about in real time. Physical probe doesn't exist, or it's practically impossible to monitor it in real time in situ. So you pull a sample, you send it to the QC lab, you wait, whatever, 4 to 8 hours. The concept of a soft sensor is that it uses process data that you're already collecting, so temperatures, NIR readings, mixing parameters, temperatures, pressures, etc., to infer that quality attribute now in process. Then the model tells you what the lab would tell you hours from now, and it's not perfect, but it needs to be good enough and importantly on the right time horizon in order to take action. So the four steps on the left of the slide are the traditional approach, and then the middle is what the soft sensor approach changes fundamentally. And the 3 points there are worth emphasizing. So number one, real-time inference. Process data predicts quality now, not hours later. Operationalization, ability to get the output into the control system that operators can actually act on, right? And then validating those inferences against lab results. And then operator trust. A perfectly accurate model that operators don't trust really delivers zero value. Then the quote at the bottom is really the takeaway. So the model is only 20% of the level of effort, and the other 80% is making sure the right person has access to the inference, it can act on it at the right time and in the moment, which really sets us up for pillar three, act. And this is the layer where I see the most value left on the table. It's also the least technical, so it's often overlooked. The value of any analytical capability is exactly zero until someone changes a decision based on it. The page shows that contrast directly on the left side. Typical implementation, analytics tool produces insight, dashboard displays the data, operators glance at it occasionally, but no action really taken. The right side, right? Workflow integrated implementation. The model generates a prediction, contextual alert in the HMI, in the MES, in the systems that people are already using, and the operator is able to act on that decision point. The outcome measured, fed back into the model, and the value is tracked in production KPIs that are baselined and measured on an ongoing basis. Now, the note at the bottom is the design principle. The best implementations are almost invisible. The recommendation appears inside the existing workflow, not a separate app, and that's the goal. Or in many cases, you want to make these fully autonomous. However, the typical starting point is often human in the loop. So the integration into existing decision processes actually matters a great deal. This is also where change management becomes as important as technology, building operator trust, demonstrate early wins through explaining why the model says what it says. That's the human side of the implementation and what really makes it stick. Now, three primary ROI levers, and all three are on the page with benchmarks. So quality 20 to 40%, scrap reduction, in-process quality prediction, can catch drift before defects occur. SPC, statistical process control with real-time model output, reduces the false alarms, and root cause analysis can be accelerated by connected data. My throughput, 5 to 15% uplift through dynamic scheduling optimization, optimizing changeovers and batch sequencing, bottleneck identification from real-time OEE decomposition, real-time constraint analysis, and ultimately reducing unplanned stops from predictive alerts. And then on the maintenance side, 30 to 50% unplanned downtime reduction, condition-based monitoring, replacing calendar-based PMs, failure prediction, shifting spend from reactive to planned, and then parts inventory optimization from usage pattern analysis. These are real-world McKinsey and LNS research benchmarks. Again, no silver bullet, but the results are real. So the question is, how do we sequence it? And this page is maybe pretty intuitive, but the worst mistake that you can make is trying to build everything simultaneously across a full plant footprint or full operational footprint. That's the recipe for a major multi-million-dollar project that stalls. So the sequencing principle is prove before you scale. Phase one, prove it, first 90 days. At least one high-value data-ready use case, not a pilot, but a deployment, and tied to a KPI that you already measure. And this distinction matters. Right? Pilots prove technology works, and deployments prove the business value. So the outcome is ROI, evidence, and credibility. Sets you up for phase two, foundationalize. Try to accomplish in the 90 to 80-day time horizon. Use the early wins to justify expanding the data foundation and set up for success for the next wave of capability uplift. You build the internal capability as well as the internal support staff and capability as well as you go. And any external partners that you've been partnering with start to transition knowledge to a sustainment team. The outcome, scalable infrastructure, and a focused team that owns it. Sets you up for phase three, scale. And you want to try to time box this, set targets in the 18 to 24 month time horizon range. Seek to expand across lines and plants, drive real measurable change, identify and enable internal champions to drive the adoption, and your data infrastructure starts to compound value with each new use case that you're able to deploy. But the warning at the bottom is also worth stating. The manufacturers who focus solely on high value and not data ready from the start are contributing to the 70% failure rate. And that's the trap, really, that phase one is specifically designed to help avoid that through rapid prototyping and proof points. I want to close the framework section by emphasizing how this can work regardless of your current state. So here are two side-by-side applications at Hitachi facilities, Greenfield in Hagerstown as referenced before, and then a brownfield at Omeka Works. So with the Greenfield on the left, step one, connect, implemented a unified data layer built into the factory architecture from day one. Step two, analyze, deliver AI quality inspections, digital twins, predictive maintenance, all operational at time of opening. And step three, act. So real-time supply chain visibility and decision support embedded into operating workflows. Now this is setting them up to transition into agentic and autonomous workflows. All three layers deployed simultaneously at launch. So on the right, in the brownfield case, and by the way, this was the first factory owned by a Japanese company to receive World Economic Forum Lighthouse distinction. So you know the results are there. But step one, connect, right? Same steps, starting with visualization, making the factory information accessible and reliable, deploying RFID tracking for WIP product, set up for stage two, analyze. So intelligence that was built incrementally from statistical process monitoring at first, then layering in predictive models, and doing this in a high mix, low volume environment. And then transitioning into step three, action or act, decision support layered as each data foundation element proved reliable. Um, each layer earned before advancing to the next, and as a result, uh, in aggregate, achieve 50% reduction in production lead time without compromising product quality. So the principle is the following, really regardless of where you're starting. Connect, analyze, act. It's just that the scope and speed of deployment at each layer is calibrated to your relative starting point. And that's how you build something that lasts. So I want to preempt the common objectives, at least three objections, at least three that I commonly hear. Number one, our data isn't ready. And that's actually almost always true. But it's also almost never as disqualifying as it feels. No manufacturer has perfect data. The question is your data good enough for this specific use case that you're seeking to enable? Start narrow, prove the value, then justify the broader data investment in establishing the broader foundations. Number two, we don't have the internal expertise, and this is also real. And it's why the engagement model actually matters a lot. External partners should deploy with your team, not instead of your team. And as the slide puts it, if the partner leaves and the system fails, it was never really deployed. And that's really the test of a successful deployment. And then number three, we can't justify the ROI. And this is often a sequencing problem, not an investment problem. So that phase one exists precisely to generate the ROI evidence before you go commit to phase two and phase three, et cetera. So a properly scoped first engagement should pay itself off and be tied directly back to demonstrable KPIs to prove it. Now let's look at the winning behaviors. So three behavioral patterns that we see consistently in the manufacturers who are winning. And I'll call out that these are organizational behaviors, not technology investments. So number one, define success in business terms, not digitize the plant, but instead 15% scrap reduction on line three by Q3. So a target, a KPI, an end date, something clear and measurable. Then technology becomes the means, not the overall objective. Number two, treat data as infrastructure, a conscious decision that data is not an asset, not just a byproduct of operations, but something that someone should own with an architecture and a governance model around it. And then number three, build internal champions. So one person inside, usually in operations or engineering, someone who owns the digital transformation and specifically brings both the floor credibility and leadership authority. And without both, it often doesn't stick. So I want to make sure that you leave today with more than just ideas. So here are three steps that you can do to take action right now. Step one, you can apply the framework this week. Use the data readiness matrix. Where do you have high business value and reasonable data readiness? That's the intersection that should serve as your starting point. And you can do this without any external help. But of course, if you'd like, we can provide a framework to help you get started as well. Action number two, engage in a structured assessment. So not a sales conversation, but an actual diagnostic. 2 to 4 weeks, understand your current state, your data landscape, your highest priority opportunities. A good assessment pays itself off in the clarity that it creates, and it addresses the true number one blocker to getting more from less, and that's having the right strategy in place in the first place. And then action number three, design your phase one for proof to production, not a pilot, but proof to production. So tied to a KPI that you already measured, designed to use technology that you can prove that works, and scope to deliver measurable business value, not just implementing the technology. So if you want to have that conversation with us, you can reach out. This is the exact kind of work that we do on a daily basis. And with that, I just want to thank the audience. Genuinely enjoy these conversations because the problems are real, the solutions are proven, and the gap between where many manufacturers are today and where they could be in 18, 24 months is very actionable. So yeah, thanks, Ellie. Let's open it back up for questions, and I'll stay on as long as we have conversation.
Awesome. I have a couple questions here, but if you haven't put a question into the chat yet, feel free to drop it in there and we will take some time to answer those for you. So, first one here, you talked about the importance of operator trust in AI models. How do you actually build that trust in practice, or what does that process look like on the plant floor?
Yeah, that's a great question, and it's one of those part of the implementations that often overlooked, right? So, I mean, the first thing is you can't ask operators to trust a model before the model has earned it, right? So, running the model in maybe an offline or a shadow mode as a way to get started, um, get it generating prediction, have a human in the loop to validate its performance, demonstrate repeatable success. The I think second real key factor that is transparency, and I think there's a lot of conversation about black box models, but especially today with the AI tools that are at our fingertips, having explainability baked into the design of these solutions from the outset, and having a stack trace back to the source information that provides justification and support to the recommendations that are made in, that it's making, um, really critical factors. And there are some, technological tips that you can put in place um, to provide that kind of backing. Maybe I'll save some of those details for this conversation, but like happy to, for whoever's interested in that, to have a follow-up dialogue on some of those more technical tricks that could be put in place in order to really validate the determinism of some of these tools.
Great, thank you. Next one here, for manufacturers just starting out, what's the single most common mistake that you see them make in their scope of their first digital initiative, and what should they do instead?
Yeah, it's probably scoping to the technology rather than the outcome, or the architecture or the foundations rather than the outcome. I couldn't tell you how many conversations that I have where even clients ask for, hey, can you implement a machine vision system for this particular type of sensory insight? And then you start asking the question why, and why again, and why again, and sometimes it takes a few iterations to get to the point of really understanding what the business value is. And oftentimes you find that um, the real measurable KPI, or the business value that can be unlocked might not even be solved by the technology that somebody's initially asking about. So um, I think that's the number one consideration, is really anchoring on the value. Now, that said, it is a healthy balance. And we talked about it here. Anchoring only on the value without the understanding of the technology's readiness to go deliver that value is a common trap as well. But it's definitely identifying where the opportunities lie that are in that upper right quadrant of value potential, and data readiness and technology's ability to deliver the value. Then committing yourself to delivering those outcomes.
Great, thanks. Well, that's all the questions we have. So I think we'll go ahead and wrap up early then, give you some time back into your day. And if we didn't answer a question that you had, or if you think of something else, feel free to reach out to us. We're happy to answer anything else that comes up for you. But thanks, Chris, and thank you all again for joining us today. I hope you're walking away with a better understanding of how you can optimize your existing assets. And if you'd like to get some further guidance on how you can start implementing this framework that we presented today, please reach out to us. You can fill out our contact us form that is on our website at flexwareinnovation.com, or you can reply to the email I'll be sending you shortly today with the recording of today's session. But thank you again and hope you have a great rest of your day.